Hello, this is Andrea Hendricks. I would like to talk to you about graphs of quadratic equations. The focus in particular will be equations of the form y is equal to a times x minus h squared plus k. We're going to look at the most basic of these functions and then look at how the parameters a, h, and k affect that basic function. Also, you do not need to worry about the concepts of domain and range. You will get into those in college algebra and math modeling. You recall that we've been studying up until this point quadratic equations, that is, equations of the form ax squared plus bx plus c is equal to 0. We used things such as factoring, the square root property, completing the square, and the quadratic formula to solve equations of this type. We're going to now turn our attention to quadratic functions. And remember, quadratic functions, or that word function, can also be represented as f of x or y, but basically it means for one input, or for any input, there is exactly one output. But a quadratic function is a function of the form y is equal to a times x squared plus bx plus c, or an alternate form that we're going to focus on is y is equal to a times x minus h squared plus k. You can convert from one form to the other. That's really not going to be the focus of this course. You'll get into that in a later course. But in general, the graphs of quadratic functions are called parabolas. And a parabola is something that looks of this form. It can be a parabola that opens up, as in the first example that I've drawn, or a parabola that opens down. Okay? So let's take a look at the basic quadratic function, and then we'll again look at those values of a, h, and k and see how they affect this graph. So the basic quadratic function, we could of course go to the calculator and plug this in, but I think you could do this just by hand. If I want to graph any equations, if you recall, we need to form a table, and we need to input values for x and then solve for y. And I like to do some negative values and some positive values, and of course 0. So if we put in negative 2 into this function, our output is obtained by squaring our input. Negative 2 squared is 4. If we input negative 1 and square it, we get positive 1. If we input 0 and square, we get 0. Input 1 and square, we get 1. And input 2 and square, we get 4. So some ordered pairs that lie on the graph of this function are negative 2, 4. So if we go left 2 and up 4. Negative 1, 1. 0, 0. 1, 1. And then 2, 4. And if we connect these points, hard for me to do on the tablet, you would get a shape that looks like this, which is a parabola. Okay. Now this point 0, 0 is called the vertex of the parabola. The vertex is always the highest or the lowest point on the parabola. Since in this case our parabola opens upward, this vertex is the lowest point. There is no highest point because it extends indefinitely as we go in the positive values of y. Now also notice some interesting facts about the parabola. Around this vertex, if you will, notice what happens as we go out evenly spaced from the from the vertex in either the x or positive direction or negative direction. That is, if we go out one direction, the negative, and one direction, the positive, notice that our y values are equal. The same thing happens if we go out 2 left and 2 right, our y values are equal. Okay, so there's some symmetry about the line that goes through the vertex. That is, on one side of the vertex, we can always find the mirror image of it on the other side of the vertex. And sometimes that can help you with completing ordered pairs and such. And I'll talk about that as we go through this process. But right now, just a unique thing that happens with these functions. Okay, so what I want to look at right now are graphs of the form y is equal to x squared plus k. So that is, we're taking that basic function x squared and we're adding a number to it. And that value k is a real number, so it can be positive or negative. And I've looked at this example, y is equal to x squared plus 1. And I've already gone to the calculator, and in y1 I've input x, the variable x, and I've squared it and added 1 and graph. And you remember our basic function went through the origin as its vertex. But notice here the vertex of this parabola is the point 0, 1. So notice that when we add 1, that basic parabola is shifted up 1. And so that affects our vertex to become 0, 1. Now, when we have y is equal to x squared plus 4, so our value of k here is positive 4, notice what happens. Our vertex goes up to 0, 4. Okay? So again, it took that basic function of x squared, and we increased it by 4, which raised the graph up 4 units. Now look at y is equal to x squared minus 1, so our value of k in this case is a negative 1. When we graph it, notice that what happens, the vertex now goes down to the point 0, negative 1. So this time our basic graph of x squared was shifted down 1 unit. And likewise, y is equal to x squared minus 4. Our value of k in this case is a negative 4. Here we see that the vertex of that is 0, negative 4. So again, that basic graph of x squared was shifted down 4 units. So hopefully you get the idea of what we can conclude here. If we look at a graph y is equal to x squared plus k, again where k is some real number, the vertex of that graph will always be 0, k. Now if k is greater than 0, that is k is positive, the graph shifts up k units. And when I'm talking about the graph shifts up, I'm talking about that basic graph of y is equal to x squared shifts up k units. If k is less than 0 or negative, the graph will shift down k units. Okay. Now let's examine the effect of this x minus h squared, that is inside change. Okay, so the previous problems I called them an outside change because it was outside of that basic function or outside of the squaring function. So graphs of the form y is equal to x minus h squared, where h is a real number. So I've looked at this problem, y is equal to x minus 3 squared, where in this case our value of h is 3. And why is it 3? Because notice that we have a minus sign inside there. So if h is 3, notice what happens. Our vertex now goes to the point 3, 0. So notice this time it's shifting it along the x-axis. Right, when we had that change of k, we shifted up vertically. So this will shift that basic function right 3 units. Okay. Now y is equal to x plus 2 squared. In this case, the value of h is negative 2. And again, that's because we have a minus sign in here, so we have to do the opposite of this to find out what the h value is. Another way you can think about what value makes that inner expression equal to 0. and that could also determine your value of h. So if I said x plus 2 equal to 0, x is negative 2. Okay. Well, I've already graphed this on the calculator and captured the screen, but notice here our vertex is negative 2, 0. So this time that interchange shifts the graph left and right. Oops. Okay. So our conclusion is if we have y is equal to x minus h squared, the vertex of that is going to be h, 0. So again, we're affecting the x value inside this parentheses, and so it's affecting the graph in the x direction, which is in the left and right direction. If h is greater than 0, the graph will shift right. And you have to be careful in your mind here. If it's greater than 0, that means you're going to have a minus some number inside there. So it's going to be x minus something. Okay. If h is less than 0, we shift left. Now again, if I have a negative value of h, that's x minus some negative number, which is really going to be x plus some number. Okay, so if it's minus inside, we're shifting right. If it's plus inside, we're going to shift left. So it kind of goes the opposite of what you might initially think. So before we go on, let's just review a few problems. If I have y is equal to x squared minus 5, or y is equal to x minus 5 squared, let's talk about what the vertex would be just simply by those forms. Y is equal to x squared minus 5. This is a number outside of the square, so that's affecting the y value, so it's a vertical change up and down. So y is equal to x squared minus 5 has a vertex of 0, negative 5. Y is equal to x minus 5 squared. Notice the change to x is occurring inside the squaring function. So that's going to change the x value of the vertex. And x minus 5 would be shifting right by 5 to the 5, 0 for the vertex. Okay. Now let's look at what happens when we combine the x and y changes. So that is when we have y is equal to x minus h squared plus k. So we have an inside change, that is something going on with the x before we square, and an outside change. So if I do this, y is equal to x minus 2 squared minus 4. Now understand my value of h is 2. My value of k is negative 4. Okay. Remember, k was plus k, so whatever sign is with the k is the sign of the change. Well, look at the graph. The vertex here is over 2, down 1, 2, 3, 4. So my vertex is 2, negative 4. Y is equal to x plus 1 squared minus 3. My value of h in this case is a negative 1. Remember, the inside is the opposite of the sign, but the k is negative 3. Well, what's happening with my vertex? Over 1 in the left direction, down 3 units, negative 1, negative 3. And remember, what is my vertex? It is either the highest or the lowest point on the graph. And also, if you kind of draw an imaginary line through that, there's going to be a mirror image of the left side and the right side of the parabola. Y is equal to x plus 3 squared plus 1. Well, in this case, the value of h is a negative 3. My value of k is a 1. We'll look at the vertex here. From the origin, go left 3 and up 1, which is a point negative 3, 1. So can you make the connection? In this graph, y is equal to x minus h squared plus k, the vertex is always going to be h, k, with h being the opposite of whatever's inside here, k being exactly what the outside number is. So just as I said there, our conclusion, y is equal to x minus h squared plus k, has a vertex of h, k. So let's just practice. If I have y is equal to x plus 2 squared minus 6, y is equal to x minus 6 squared minus 2, y is equal to x plus 4 squared plus 3, and y is equal to x minus 9 squared, y is equal to x squared minus 7. Let's see if we can find the vertex of each of these. If you want to pause it for a minute and try to do it before I give away the answers, you can do that. So let's look at our solutions. Y is equal to x plus 2 squared minus 6. Well, the value of h is negative 2. The value of k is negative 6. So our vertex is negative 2, negative 6. And you could confirm all of these on the graphing calculator. Y is equal to x minus 6 squared minus 2. Okay, my value of h in this case is 6. My value of k is this negative 2. So that vertex would be 6, negative 2. X plus 4 squared plus 3. Remember to take the opposite for the h, so that would be a negative 4. The outside number is my k. Now y is equal to x minus 9 squared. I have an inside change. It's the opposite of what I think, which would be positive 9, but there's no outside change, so that is just 9, 0. Y is equal to x squared minus 7. There's no change attached to the x before the square, so that vertex is 0. The outer number is my y value of the vertex, which is negative 7. Okay. Now we have one more change to look at, and that is this a. That is, if we have some coefficient of the x squared. If you notice in all the problems I've done before, that value of a has always been 1, right? Because there's been nothing multiplied by the x squared other than 1. And if you recall, all of those parabolas were opening up, and that has to do with the sign of that value of a. Turns out that if a is positive, our graph will open up. Okay? I've heard someone say that if you're positive, you're smiling all the time, right? So that looks like a smile. Well, there's some other things that actually go on with it. We're not going to get into that too deeply in this course. But if the value of a is larger than 1, so we have y is equal to 2x squared, it actually stretches the graph. And whenever I say stretch, it's almost like if you can envision someone on the ends of the graph up here pulling it up, it makes it more narrow. You don't really have to know that at all in this course. The main thing you need to know at this point is that if a is positive, the graph is going to open upward. Now, what is our vertex? Notice a doesn't change our vertex rules because the vertex is only dependent upon the values of h and k. H is the number that's added or subtracted to the x before we square. Well, there's not a number added or subtracted in there, so that's 0. The y value of the vertex was a number on the outside here. Well, there's not a number there other than 0, so it's still 0, 0. Now, if we look at y is equal to negative 1/4 x squared, when we have a value of a that is negative, then our parabola opens down. And you might can understand what I'm about to say here. A negative person is frowning all the time, right? So if a is positive, they're smiling, the parabola goes up. If a is negative, they're frowning, and the parabola goes down. The other thing that you'll get into in a later course is that if this value of the coefficient is 1/4, disregard the negative sign for just a minute, but if that value is small, if it's between 0 and 1, the parabola actually widens. And you can kind of see that here, right? Okay, it's very wide, and that's what that value does. But again, the only thing you really need to know is that A positive, it goes up, A negative, it goes down. Now, so let's put all these changes together. If we're looking at y is equal to a times x minus h squared plus k, the value of a only has to do with the direction it's opening and also how fat or skinny the parabola is, but we really won't get into that now. The vertex is the point hk. So k makes the parabola go up and down, meaning shifting up and down, not changing the direction of the parabola. H makes the parabola go left or right. And then the A has to do with the direction of the parabola. Okay. So let's look at one where we have all of this, and I want you to actually do some things first just from your knowledge of what we've just talked about, and then we're going to go a step further and actually plot it by hand, and then I'll show you how to do this on the calculator. But if I'm looking at my A, H, and K, A in this case is 2, which is positive, so we know the parabola is going to open up. H in this case is 3, right? And K is negative 4. So that tells me that the vertex of my parabola is going to be 3, negative 4. Now, if I wanted to plot this by hand, the vertex is 1 point, so I need to find some other points. And if you remember how I talked about before, around that vertex we get points that are mirror images of each other. So if you were going to plot this by hand, what I would tell you to do is let the vertex be your center point, and then we need to go to the right and to the left of that vertex to get some other points in our graph. So let's just say if I plug in the value of 1 for x, so that's 2 directions smaller, 2 units smaller than my 3. Let's also go 2 units larger than 3, and we'll get 5. So if I plug in 1, now these are just plotting by hand, so you can do anything really, but the main thing is you want points on each side of the vertex. And I'll show you some other x and y-intercept points that you can also get. But if we plug in 1, we're going to go back to this graph. Y is equal to 2 times 1 minus 3 squared minus 4. So you'd have 2 times 1 minus 3 is negative 2 squared minus 4. Remember, order of operations, you square before you multiply. So negative 2 squared is 4, and then minus 4. So what is that? 8 minus 4, which is 4. Now if we put in 5, we get 2 times 5 minus 3 is 2 squared minus 4. But if we square the 2, we get 2 times 4 minus 4, which is again 8 minus 4 or 4. And remember what I said, if we go the same distance on either side of the vertex, we should get y values that are the same. So if I wanted to graph this by hand, now preferably you would have graph paper, and I should have inserted a graph here, but I think you'll get the point. So let's see, my vertex is 3, negative 4. Then I have 1, 4 is here, and then 5, 4. Okay, and so I would then draw my parabola. It's hard to do on this tablet because I can't really turn it too easily. But there, that would be the graph of my parabola. Now, just to review some concepts that we talked about earlier, and then I'll close with one more screen. You could also find, if you wanted to, the x and the y-intercepts. Do you remember the x-intercept is when y is equal to 0. So if I set this parabola equal to 0, I could solve that by the square root property. Right, that would be the easiest thing. If I isolate the x, or the term that's squared, or the factor that's squared rather, I'd have 2 times x minus 3 squared equals 4. Then I could divide by 2 to get x minus 3 squared is equal to 2. Then we can apply the square root property to get x minus 3 is equal to plus or minus the square root of 2. So that would be 3 plus or minus the square root of 2. Now I'm sure my graph is not very accurate, but the square root of 2 is around 1.4, so 3 plus 1.4 would be 4.4. So my parabola should be somewhere around 4.40. Now that's definitely an approximation. If I wanted to be exact, I would say 3 plus the square root of 2, 0. And then 3 minus 1.4, what is that, 1.6? Okay, you can tell I'm a little bit off of my graph, but this is where my other intercept point would be. So 3 minus the square root of 2, 0. Now my y-intercept, if you allow me to put it in here, my y-intercept is when, what, x is 0. So I replace x with 0. So we would do inside parentheses first. 0 minus 3 is negative 3. Then I have to square it first. So negative 3 squared is 9. So that would really be 18 minus 4, or 14. So it should cross my y-axis at 0, 14. Okay. Now, let's just confirm on the calculator. I had already done this. I'd entered, and I'll show you how to do that here. Y is equal to 2 times x minus 3 squared minus 4 to confirm that I do have a 3, negative 4. And then my x-intercepts were at that 3 plus the square root of 2, 0. And then 3 minus the square root of 2, 0. Okay. Now on the graphing calculator, I'll close by this. If you press y equals and input 2 times x minus 3, close parentheses, and square it, and minus 4, and press graph, you'll get the graph. The other cool thing is if you press second graph, you'll get a table. And notice here, this is my center point, this 3, negative 4 that I was talking about. And around it, I have a mirror image, right? 2, negative 2, 1, 4, 4, negative 2, 5, 4. I can see that one more time, 0, 14, 6, 14. So if you can find that center point, that's going to be your vertex. And then those other points would go either above or below, depending on if you have a highest or lowest point for your parabola. Okay, so that concludes this lesson about graphing quadratic equations. If you have any questions, please don't hesitate to contact me. Thank you.